Okay. So this is our, I guess, project 6 group project with Russell, me, Bobby, and Jason. Um, so first we imported all of the modules I need, which is math, time, and random. And I'll first start off with explaining the I guess the function A, or is sorted. First I declared valid as true, so just to like declare my variable. And for I in range of basically the length of the list subtracted by 1, since I am comparing both the previous and the next item in the list. I can basically just do a generic comparison of which one is greater. So, and if that happens, the previous item in that list order is actually greater, it will immediately turn valid into false, break that loop, and then just return the value of valid. So moving on to anagram is anagram. It takes inputs in two strings. I also declare valid as false. And here I get rid of any white space or uppercase letters using replace and lower. Do that for both strings, and then I immediately compare them just to see if both of them are the same thing. It'll immediately return true. Otherwise, it will check if they're both the same length, and then we'll actually check if they are anagrams by basically going through each, splicing the string into individual letters and seeing if they're both in the same count or the same number of letters. And if not, it's going to immediately turn valid to false, break that loop, and return the value. Moving on to has duplicates. Declare valid again, make that one false. And for I in list, basically going through each item in the list, it's going to see if there's more than one instance or two instances. This just to see if there are any duplicates, and if there are any, it will return true.
Okay, that was the end of your functions, right?
Yep, that's it.
Okay, so now we'll start with the functions I did, which was I think D, E, and F. So we have function, well, the remove duplicates function, and this is going to be a function that's going to check for duplicates inside of a given list and then just remove those duplicates. So we take in a parameter of list, and we're going to check each element inside that list using a for loop, and we have a nested while loop inside this for loop that checks while this element has a higher count of 1, like so if there's like 2 or 3, then we're just going to remove the element. And then by the time it goes through every single element, there shouldn't be more than one occurrence for each element. And so then we just return this new list. The next function is our read file function, which is going to check which method between the appending and the idiom method for adding words to a text file to see which one is faster or more efficient. So the first thing we do is create an empty list, just called word list, and we make an empty string, just called full word, and we have to drag the mobi.txt file inside of our directory so that we can open this file, and we set f equal to the opening of the mobi.txt file, and then we read those files so that we can add words into it. And so the first method we do is the append method, and it's going to basically just iterate through each individual line in that text file and then just make a list for each of the lines inside the text file using the dot split. So we start a timer here, t0, and because we want to count how long this takes to execute. So we have for line in read text, so we're iterating through the read text variable, and we set words equal to the list of each of those lines, and then we check each word inside those lines, and we're just going to append it to our empty list we had from earlier. And then we have a variable called t1, which is the current time minus the time we started before we started our for loop, which will help us calculate how long it's been throughout this for loop. And then now we have the idiom method, and we do the same thing where we want to check how long it takes for this to execute. So we make t2 equal to time.time, and we have to, our word list, we're just emptying it out again. We're just, because it had some words in there earlier, now we want to empty it out this time. And we have a similar type of for loop where we check each line in the text and create a new list based off those words, and then we check each word inside those lines and then add words to those empty strings, and then create a new list off of that. And then we have t3 equals time.time minus the time we calculated at first, so that we can see how long it's been since this for loop started. And then what we can do is we can compare those two times to see which method is faster than each other. And then we have the bisect function, which is our f function, and this also takes a parameter of a list. And the first thing we do is ask for an input. We set target equal to input, and the user is going to input some letter or some sort of a string value, and we're going to check if that is inside of our list. So the first thing we do is we create two Boolean values, found target and will check, and we're going to make found target equal to false and will check equal to true, and we need these so that our while loop can be set to true or false. And so we make we just sort our list because we wanna be able to check inside of a sorted list. So then we have to create three new variables, which would be the middle, the max, and the minimum. This corresponds to the middle element in that list, the maximum value of the list, and the minimum value of the list. And so we set the middle equal to the length of the list divided by 2, so it gets the median. And we set max equal to the length of that list minus 1, so we get the last element. And we initialize minimum to be 0, but it can change during the while loop. So we check while found target is equal to false and will check is equal to true. We're going to execute this sequence of if statements, and the first one we want to check is if the target value, so the input, if that value comes before the word in the middle of the given list. And if that's the case, then we want to search the first half of the list. So we make our maximum number the middle number, and we change our middle number to be the first half of the list. But if this wasn't the case, then we check if the target value was at least less than the max. And if that's the case, then we'll set the minimum equal to the middle number, and the middle number equal to the second half of the list. And in a few cases, the target value might already equal the middle of the list, or it might already equal the last element in the list. So then we can just simply say we found our target right away, and we can just break out of the while loop. And there's if we have a value that wasn't inside of our list, then we'll have a while loop occur. An infinite loop occur, because the conditions won't ever be set to being false. So what I noticed when I was executing this program was that there was a few patterns that would occur with the minimum and maximum and the middle values when the index's range was when it wasn't inside the index's range. So I added some checks inside of here to see if those patterns occurred, then we know that we have an infinite loop. And if we have an infinite loop, that we can conclude that the target value is not inside of our given list. We also check right after the while loop ends. We check if we found our target, and if we did, then we can return just the value of target. But if we didn't get, if our found target was never set to true, then we'll return none. Okay, Jason, you can go ahead.
So then I had to do parts G and H, and then for part H right here, we basically open 3 files that we either write or read in, and then we set a variable that reads it and then we set another variable that makes a list out of the entire text. And then after that, we have another file that we are writing in, so then to display the results. So then we write into the file the how many words are in that text file based off of the list that we created. And then we have an alphabet list that basically has all the lowercase letters of the alphabet. And after that, we just set variables that we're going to be using later, so like strings and empty lists and stuff. And then in our for loop, basically for every letter in the alphabet, we just check like how many times that letter occurs within the entire list. And then we set that variable equal to lower count. And then the frequency is basically just adding on how many of the letters that we have. So say A is like 4, and then B is like 3. So then lower frequency, we just add them to get 7 to get the total amount. And then we do the same for the uppercase letters. So upper count would be set equal to the count of the uppercase letters. And then we just add the total into the upper frequency. And then we have total letters, which is basically the entirety of all the letters added up, so lowercase and uppercase. And we have an empty list that we append the total letters to, because it would just like display the all the like the sum of the letters for each letter. So like it would just display like each part of like A, B, C. And then in our next for loop, we have the entire text file. We're just checking in that text file like every word for in the list. And then after we have another for loop to check, because in our list we have just pure words, but then we need to get the letters, so we have another for loop to check like the length of the letter. And we go individually of the letters to get it, and then we have, depending on the letter, if it's in the range 65 to 91, depending on its ASCII value, because 65 to 90 is like the capital letters. And then if it's a capital letter, we are to change it to a lowercase letter, so then we just append the lowercase letter after we change it to a new list. And then we do the same, but this time the range is from 93 to 122, which is lowercase letters. So then if it's a lowercase letter, it would just change it to an uppercase letter. But then if it's not a letter, it would just append it anyways because of like the punctuation we need that. And then for the second for loop within our main for loop, we just check the main list that we created, which will be a word, and then we check we basically add every list or like every letter within that list to a string and just keep adding it. And after we get that, go through the entire list, we just reset the list in order to like not get duplicate words. Because if we don't reset it, it would just keep adding on words that we don't need. And then after we just have it written to another file to display like how like the opposite is. So like if it was lowercase letters, it would be uppercase in that file. And then next we have I equals 65, which is the ASCII value of capital A. And then in that for loop, within the letter frequency, we basically are just writing to a file of like every letter and then how many times it shows up within the text file. And then for after that, we just have just like write stuff to files, which is, so we just write how many times uppercase letters show up within the text file, and then we have the same thing, but for lowercase letters, how many times it will show up in the text file. And then after, since we're just done with all the files, we just close all the files. But then we have to reopen the files for another use, which is just to read the files to display them. So then we have file 3 opening to display like the results of like all the letters and its frequencies. And after that, we just close it. And then we are to create a plot of all the datas of like the how many frequency of each letter there is. So basically, we import matplotlib.pyplot, and then I created a list of all capital letters in order to make my graph have all capital letters as their x values to make it look cleaner. So then we just set the frequency as a y value to see how many times it shows up within the text file of every letter. And then we just label the x and y values as like what they would be to tell you if you're just lost on what it's supposed to be. And then we have the title of what it's supposed to be, which is the letter frequency, which is how many times it shows up. And then it would just display the graph after. And then for part G, we are to get input from the user. So we ask the user for input. And then after I just made the entire user input lowercase letters to make it easier when I have to sort it later. And then we make the user input into a set of lists. And then we declare more variables that are empty lists, and then declare a dictionary that we're going to be using later on. And then again, we have a list that just contains all the lowercase alphabet letters. And then since our user input was just one big string, we separate the entire string into letters within a list, and then we like append it to a list. And then we check that list, and then we run it through the main alphabet list of the lowercase letters. And then if it's not, or if it's in the letter, like the list of alphabets, then it would just be appended to another list. So then this is to get rid of like the punctuations, like commas and like question marks and stuff. And then we resort the list in order to get it alphabetically, because that's one of the requirements we had to do. And then in our next for loop, we basically just go through the list of the sort, like the sorted list. And then we just count how many times a letter repeats itself. And then we just put it within the dictionary that we had earlier. And then after we get the dictionary, we just take out the letters and the numbers into lists. So like we just set sorted list equal to the list all letters, which are the keys. And then we have value list, which is just the list of all the values that it had. So like if it was repeated, it would be like more than one. And then after that, we just basically print as many times as like the length of the list is. So then we would just print whatever letter it is, and then just like how many times it repeated. And then we have our main function.
So in our main, we're basically just testing each and every single one of these functions using two randomly created lists that I made. And these example lists are going to be our arguments inside of each of these functions. And so the first set of print statements are just checking if it's just going to print true or false if the list is sorted correctly. So in the very first function, we were checking if our list is a sorted list. So we put our test list inside of here. So this list right here, from lowercase a to capital K. And it's going to be this one is probably going to return false because um, the lowercase letters are actually should come after the uppercase ones, so we would know this one's probably going to be false if it was sorted. And then the next one is a example of an actual sorted list. So go from 1 through 6. This one would probably return true because this is a sorted list. And the second pair of print statements is checking if these two strings are actual anagrams of each other. So we're going to print true or false if our two given strings are anagrams of each other. So the first pair we use is listen and silent, and these are two anagrams of each other. So if we set listen and silent as arguments inside of is anagram, we're going to most likely get true. But if we put something like hello and world, these aren't anagrams of each other, so the is anagram function is going to return false. Our third set of print statements is going to check has duplicates function. So we pass in test list as an argument into has duplicates, and test list doesn't contain any duplicates in here because there's no recurring element inside of here. So if it's passed inside of here, it's going to return false. But if we pass in something called list with duplicates, which is this one right here, there are recurrent elements like 2 and 9, so this is going to return true because it will find duplicates inside of that list. Bobby, do you want to explain this one real quick, this birthday?
Yeah, for sure. So I just created a empty list called birth, and created a for loop with 23, just basically to randomly create 23 numbers and append that into the birth list. And then basically I used a format string to format it correctly into that list.
And so
And then sorry.
Yeah, so we basically pass in that birth list into the has duplicates, and if it detects any, then we might get true or false. If the randomly generated birthdays have 2 recurring birthdays, then we're going to have true. If it didn't generate 2 matching birthdays, then we're going to return false here. So it's going to say there were matching birthdays equals true or equals false. This set of print statements is checking for the remove duplicates function. So it's very similar to has duplicates, but instead of just returning true or false, we're going to print a new list with the unique elements only. So we pass in lists with duplicates inside of the remove duplicates function, and as we mentioned earlier, this list is known to have duplicates already. So this should return a new list with the elements from here, but without the duplicate elements. And then if we pass in the test list, which didn't have any duplicates inside of it, then we're probably just going to return the same list because it didn't remove anything because there was no duplicates inside of there. And this is just to call our read file function so that we can just print the 2 timers. It's going to print the append methods timer and the idiom methods timer, and we can just see which one's faster there. And we're going to also call the bisect function, and we can pass in any list, but in this case we're passing in the test list, the one that goes from lowercase a to k. And it's going to ask the user for an input, and it's going to see if that input is inside that test list. And then we can call the functions g through h in this one too. So I'm going to do some output. So you can see here that in this case, the random generator did not make any matching birthdays, so we got false back here. And it's asking me for a target value, so I put something like lowercase d in here. It should say that it found d inside of the test list. see in this case, the random generator actually created at least one pair of matching birthdays, so we got true in here.